First responded Professor Nicholas Griffin.
Thank you. I find myself in the slightly awkward position for a commentator of agreeing with almost everything that Professor Klein said. His conclusion is that closure principles are of no help at all to the skeptic, and this seems to me exactly right. I especially liked his argument that in establishing a justification for a belief, one is obliged, on pain of deductivism, to refute only those contraries for which there is some evidence, and that this relieves us of the need to refute any global skeptical scenarios because these are deliberately so constructed that there could be no evidence for them. Since I'm not in a position to launch an attack on Professor Klein's conclusions, I shall content myself with criticizing his premises, or at least one of them, namely the closure condition. Professor Klein has two closure principles, CJ and CK, both of which state closure conditions with respect to entailment. Now, strictly, the closure condition for knowledge with respect to entailment would be CKS, which is the third one down on the handout. I apologize for this scrappy handout. In part, it's because we were brought forward a day, but that's only part of the excuse. My handwriting's bad as well, so that compounds the offense. CKS is the strict closure condition for knowledge with respect to entailment. Namely, if X is known by S and X entails Y, then Y is known by S. So this is obviously too strong. No epistemic agent, with the arguable exception of God, knows everything that is entailed by anything that they know. Knowledge, unlike truth and necessity, does not transmit across an entailment. One obvious response to this, which Klein adopts, is to reformulate the closure principle so that the property which is transmitted across the entailment is weakened by the transmission. Thus we get Klein CK, where from X is known by S and X entails Y, we're entitled to infer only that S is in a position to know Y. This, of course, raises the question of what the in a position to modifier means, and I shall return to this shortly. An alternative such weakening, where the meaning of the modifier is not in question, is the modal weakening, CKP, which is the fourth on the handout. If X is known by S and X entails Y, then it's possible for S to know that Y. But while this is clear, if possible is used in its usual alethic sense, it seems in that sense to give us less both than we're entitled to and than we are likely to need. For the bare logical possibility that S know Y is not a property of S and Y that we are likely to have very much interest in, and CKP does little justice to the ways in which knowledge can be acquired by deductive inference. On the other hand, if we use possible in some more robust sense, physical or psychological possibility, then the notion loses the sharpness it had formerly. Moreover, and much more seriously, we seem once again to have a principle that is too strong. Among the propositions entailed by X will be some so long and complex that there is no psychological or even physical possibility of S's coming to know them. Where these considerations bear on Klein's paper is that they apply equally, I believe, to his in a position to modifier. Among the propositions entailed by X will be a truth-functional compound with so many components and connectives that S will not have time in a normal lifespan, or perhaps even in the lifespan of the universe, to even articulate it, much less to calculate its truth value when P is true. It is surely only in some degenerate sense that S can be said to be in a position to know such a proposition. Of course, it can be reasonably said that such cases of extreme complexity are of little actual significance and might safely be excluded by fiat. I'm not quite sure how the fiat that would exclude them should be stated, but let's suppose that this can be done. It does not, I think, remove the problem of complexity altogether. For the complexity that frustrates S's being in a position to know that Y may lie not in y itself, but in the entailment. There is, we now know, some pretty complicated but still quite knowable conjunction of mathematical truths x, such that x entails y, where y is Fermat's last theorem. There is no difficulty here with the complexity of y, but the train of inference which takes us from x to y is exceedingly complicated. And are we really able to say that S is in a position to know that y? I agree that the answer to that question is not so clear-cut as in the case where, say, y is a compound proposition with 10 to the 100 components. One might, for example, maintain that if S is a good enough mathematician to know that y, then surely S is good enough to at least be in the position to infer and thus to come to know that y. But suppose S is a historian of mathematics, not very able at proving things for himself, but very well informed about what has been proved by others. He knows X, as Klein permits, through the testimony of reliable teachers and the reading of reliable journals. But he has no realistic prospect of coming to know y by inferring it from X. If he ever comes to know y, he will learn it as he learnt X from testimony. Do we want to say that even so, S is in a position to know y merely on the basis of his knowing X, which entails it? I at least am not so sure that we do. But to take the matter further would involve a quite substantial inquiry into what in a position to should be taken to mean in this context. And like Klein, I propose to avoid that. Instead, I want to propose an alternative way of formulating closure conditions which escapes these problems entirely. For instead of weakening the property that's transmitted from one proposition to another across an entailment, we can strengthen the relation between the two propositions. Now, entailment, of course, is already a fairly strong relation, but it is not, as we've seen, strong enough to ensure that knowledge itself can be transmitted across it. But if entails in CKS, if S knows that X and X entails Y, then S knows that Y is too weak, a fairly natural strengthening would be to require that X not only entail Y, but be known by S to entail Y. For if S is entirely unaware of the entailment, then he can hardly be expected to know that Y. Indeed, I should want to claim that he's not even in a position to know that Y. This strengthening gives the strict closing condition CKK, which is on the list. If S knows that X and S knows that X entails Y, then S knows that Y. CKK has gathered considerable support quite beyond its merits in my view, and at least in part because it meshes so neatly with attempts to model epistemic logic on modal logic. For the corresponding modal principle, if necessarily X and if necessarily X imply Y, then necessarily Y holds. These considerations, I believe, apply also to Klein's CJ, where there is no weakening of the property that is transferred across the entailment. This fact might be obscured, however, because of a tendency to read CJ in a different way to the way in which it was stated. One might be tempted to read CJ thus, CJ exclamation mark or CJ shriek. If X is propositionally justified and X entails Y, then Y is propositionally justified. Where the notion of propositional justification employed is in some sense an alethic property of propositions, a property not relativized to epistemic agents, which propositions either have or lack. Now, I'm not myself persuaded that any such notion is properly thought of as a kind of justification, hence the exclamation mark, it's a warning. But whether it is or not, C.J. Shriek, understood in this way, would seem to be true. But C.J. Shriek is not Klein's C.J. Klein's C.J. is relativized to persons. It's stated, if X is propositionally justified for S, and X entails Y, then Y is propositionally justified for S. And Klein defines propositional justification as follows. P is propositionally justified for S if and only if S has adequate reasons available for P, which are not ultimately overridden by other available reasons. But so construed, I think Cj is surely false. For adequate reasons for Y are surely not available to S if S is unaware of the entailment between X and Y. If X does not know that X entails Y, then the availability to S of adequate reasons for X will not ensure that S has available adequate reasons for Y. This suggests the replacement of Cj by Cjk. If X is propositionally justified for S, and S knows that X entails Y, then Y is propositionally justified for S. It may be the case that you could even have a weaker link between X and Y than S knows that X entails Y, and I suggest in Cjj that if X entails Y is propositionally justified for S, then Y may be propositionally justified for S, provided that X is. I don't know whether Cjj is adequate or not, but I do think Cjk is adequate. If adequate reasons are available to S for X, and S knows that X entails Y, then surely adequate reasons are available to S for Y, whether or not S actually avails himself of them. Despite this, it still seems to me that CKK, to go back to the other closure principle, is too weak. And this because in order for S actually to know that Y, S must not only have the grounds for knowledge available to him, he must in fact avail himself of them. Consider again the case where Y is Fermat's last theorem, and X is a complicated conjunction of mathematical claims which together entail it. Suppose now, to vary the case a little, S knows that X entails Y, and S knows that Fermat's last theorem can be proven if the claims that are conjuncts of X can be proven. But let's suppose that initially S has no idea whether these claims can be proven or not. There are, let us suppose, many such conjuncts, and S comes upon their proofs one at a time over a long period and quite independently of any interest he may have in proving Fermat's last theorem. When he acquires the proof of the last one, he knows that X. He still knows that X entails Y. This is not something he's forgotten in the meantime, but at the time he acquired the knowledge of the last conjunct of X, he did not realize that he had acquired the last step in the proof of Fermat's last theorem. Perhaps he doesn't realize this for some considerable time. Perhaps he never does. He knows all the conjuncts of X without perhaps knowing that they are all the conjuncts. Or, to put it differently, he knows all the premises of a simple proof of Fermat's last theorem without realizing that they are all the premises. It seems clear that under these circumstances, he does not know that Y, even though that he knows that X entails Y, and he knows that X, at least if we assume the adjunction principle that if S knows that A and S knows that B, then S knows that A and B. Now it might be thought that what's at fault here is not CKK, but the adjunction principle. For it might be argued that although S knows A and knows that B, it does not follow that S knows that A and B unless S actually puts them together. There is perhaps something to be said for this, at least if one takes a fairly strongly occurrent view of knowledge. But this would surely be an obtuse way to try and defend CKK, for the view of knowledge CKK suggests is quite strongly non-occurrent. In particular, CKK implies that Y can be known even though it is never brought before the mind on its own as an item of justified belief. To sharpen this claim a bit, note that the point of the requirement that X entail Y is to capture in the object language the fact that Y can be validly inferred from X. Now from AB, we can certainly validly infer A and B. It's the inference rule of conjunction introduction, which is also at the bottom of the page. Moreover, if S is to acquire any knowledge by inference, he must surely know that this rule is valid. Now, if S knows that A and S knows that B, and S knows that AND introduction is valid, then by a principle very close in spirit to CKK, S knows that A and B. Lest this be thought to play fast and loose with the object-meta distinction, we could replace AND introduction, at least classically, by the adjunction principle, which is at the bottom, that if A, then if B, then A and B. If this is known, then we can distribute the knowledge operator across the entailment in 2 steps to get S knows that A and B. The upshot is that it's very difficult to defend CKK without admitting the adjunction principle because it seems to follow from CKK itself. I think that this conclusion stands even though objections can be mounted against the adjunction principle as a replacement for AND introduction, at least in relevant logic. My conclusion is that CKK, while stronger than CKS, is still too weak, and that what is really required to ensure that S actually knows Y when S knows that X is that S actually validly infer Y from X. This is the condition CPI, which is the last one on my sheet. If S knows that X and S validly infers Y from X, then S knows that Y. The requirement that X entails Y is presupposed by the fact that S validly infer Y from X. S can only do this if there is a valid inference to be made, and there is such an inference only if X entails Y. CPI seems entirely unexceptionable, for if validly inferring Y from claims which are known does not produce knowledge, then it seems nothing will. What difference does this make to Klein's treatment of the easy knowledge problem? Well, none that I'm aware of. Klein argues that the problematic step in the easy knowledge problem is not the one which uses closure to infer from the table is read to it's not the case that both the table is read and the table is illuminated by green light, but the earlier step in which the table is read is inferred from the table looks read. This seems to me exactly right. The closure step does not allow us to infer anything about conditions of illumination, so no knowledge is come by too easily there. If knowledge is arrived at too easily, it is in the prior step. But for that, closure on either Klein's reading of it or my own is useless. So there is no entailment between the table looks read and the table is read, and therefore no way of validly inferring the latter from the former. One final stray remark, that's basically the end, but one final stray remark. On page 2, Klein says that he will restrict the range of the variables x and y to contingent propositions only. I think that that's unfortunate because surely the deducing of logically necessary consequences from logically necessary propositions is a paradigm of the acquisition of high-quality knowledge. Klein, however, says that without this restriction, y could stand for a necessary truth, and the closure principles Cj and Ck would then be obviously false. What this suggests is that when he says entails, he really means strictly implies. So the problem with strict implication is that if y is a necessary truth, then any proposition strictly implies it. However, if the relation between x and y is a genuine entailment, then there's going to be no such problem. And this would lead me back to my argument in favor of the adjunction rule, that I would want to, I would have to keep the end introduction rule as a primitive, and I couldn't get it from the adjunction principle, at least not in relevant logic using entailment. But that's all I have to say. Small beer, I'm afraid. Thank you.